Hello students, welcome to Wondercom. This is in continuation of my previous videos on periodic classification. In this video, I will discuss how the term electronic configurations and quantum numbers are utilized in periodic table. In fact, this video is also important for those who want to learn about this electronic configurations. Here I have explained the filling of electrons into different cells like your K, L, M, etc. and subcells or orbitals. Subcells or orbitals like S, P, D, like with the help of different pictures and diagram to make you understand in a better way. So let's start. At first we will know what is electronic configurations and how this electronic configurations and quantum numbers are helpful in periods as well as different groups in a periodic table. We know from quantum numbers that the main energy level in an atom is defined by principal quantum number. Principal quantum number, or this is known as your small n. It is the shell of an atom, isn't it? So filling of electrons into the cell also indicates the filling of electrons into different subcells. These are denoted by K, L, M, etc. as I told you already. And this filling of cell, as I told, is also related to the filling of subcells or your orbital S, P, D, F. As we know that principal quantum is this energy level of soil cells are related to principal quantum number. Similarly, the subcells or the orbitals are related to azimuthal quantum numbers, which is represented by small l. And this distribution of electrons into different orbitals, that is S, P, D, F, is of an atom is known as or called as your electronic configuration. Let us see the filling of electrons into cells and subcells. So in the first period, n is equal to 1. Here two elements are there, hydrogen and helium. We know the atomic number of hydrogen is 1, so only one electron is there. For case of helium, the atomic number is 2, or 2 electrons are there in case of helium. So cells, you might be knowing the cell, or this is n is equal to 1, or this is the K cell, so only one electron is there. In case of helium, this is the nucleus, so 2 electrons are there in n is equal to 1, or principal quantum number, or the shell number. This is K. This is filled up. Okay, then let's see how the subcells or the orbitals are filled up by the electrons. In case of hydrogen, only one electron is there, so one s level will be occupied by the electron. So where principal quantum number n is equal to 1 and the azimuthal quantum number or the subsidiary quantum number L is equal to 0. And in case of helium, the second electron goes to 1s level with opposite spin, and this level is filled up now. Then the next element, lithium, where the third electron goes to the next lowest level, that is 2s, with principal quantum number n is equal to 2 and subsidiary quantum number L is equal to 0. That means again s orbital, so its electronic configuration will be 1s2, 2s1. You can see here the electronic configuration of beryllium, boron, carbon and nitrogen, where the 2s orbital filled up with 2 electrons, then it moves to p orbitals. Then we will see the sequence of energy levels, or it is governed by Aufbau principle. Here you can see the principal quantum number n at the left hand side and subsidiary quantum number or the azimuthal quantum number L at the top. See, L is equal to 0 means s orbitals, your L is equal to 1 means p orbitals, L is equal to 2 means d orbitals and L is equal to 3 means f orbitals. So the orbitals are arranged in according to their labels. The 1s is the lowest label, then 2s, then it moves to 2p, then 3s, then 3p, then 4s, and 3d, 4p, and so on. And the filling of electrons takes place according to this order. Now let us see the filling of electrons into different cells and subcells in the elements present in each period of the periodic table. You know how the electrons are filled up in different orbits in an atom. Here we will see the filling of electrons in different elements in different periods. In the first period, the first shell, that is your K cell, gets filled up with elements hydrogen and helium. In the second period, the electrons of the elements from lithium to neon will subsequently occupy the second cell or the L cell. Here the total number of elements are 8. Similarly, in the third period, the electrons of the elements will go to the third cell or the M cell from your sodium to argon. In this period also, total 8 elements are present. Let us have a look into the electronic configurations of the elements of second and third period. So for the second period, the principal quantum number n is equal to 2. So here the 2s and 2p orbitals are being filled up gradually, and the last element neon has the electronic configuration 2s to 2p6. Similarly, in the third period, the principal quantum number n is equal to 3 and the two orbitals 3s and 3p are being filled up gradually from element sodium to argon, which is the last element with the electronic configuration 3s to 3p6. Again, these electronic configurations in different subcells can also be represented in box diagrams, where these subcells are divided into different orbitals. Orbitals based on their orientations or magnetic quantum number. Magnetic quantum numbers. For example, S orbitals or subcell has only one orientation, so it is represented by a single box where both the electrons are accommodated with the opposite spin, and the electrons are represented by this arrow. So this one clockwise, anti-clockwise, opposite spin, which is represented by plus half or minus half as per the spin quantum numbers. Okay, so similarly in case of p orbitals. P orbitals, it has three orientations, isn't it? Minus 1, 0 and plus 1, or it can also be represented as px, py and pz. For that reason, it has three boxes in which electrons are accommodated. Okay. So similarly for d orbitals, it has 5 orientations, so it has 5 boxes. In this way, these are represented in box diagrams. So here you can see the arrangement of orbital box diagrams with increasing energies or the increasing labels from 1s to 2s to 2p, 3s, 3p and so on, based on Aufbau principle. Here in this diagram, you can see the principal quantum numbers, azimuthal quantum numbers, magnetic quantum numbers, spin quantum numbers, and the box diagrams for s and p orbitals that I have already discussed. And in the below, you can see the electronic configurations of lithium to neon with the help of these box diagrams. Here you can see the number of elements that are present in the first, second and third periods in the periodic table. And the number of elements in each period is twice the number of the atomic orbitals available in the energy label. For an example, in first period only one s orbital is present, so 2 elements are there. In the second period, s and p, so total 4 atomic orbitals are there, so 8 elements are there and so on. However, one should not get confused with the filling of electrons into orbit or the cell with the 2n square rule and filling of elements in the period with the principal quantum number n. This filling of electrons is not dependent on this 2n square rule. Okay, but however it depends on the energy levels and the arrangement of subcells and the atomic orbitals. Atomic orbitals. Hope you have understood the concept of electronic configurations of different elements in the first 3 periods of the periodic tables, applications of different quantum numbers in the periodic tables, and in my next video I am going to discuss about the rest elements in the periods from 4th to 7th, and also about the electronic configuration or the general electronic configuration in different groups in the periodic table. If you want to know about different quantum numbers, then please watch my videos on quantum numbers. You will find details of the link of those videos from the description box. The second part of this video is very important, so keep watching, keep learning. Thank you.